So, I know many of you have to deal with the same situation as me, where your phone just doesn't last throughout the day. And for me, it's that bad that I try and keep the screen on quite dull like this, just barely enough that I can see it, so that I can get maximum life out of my battery. Anyway, I was thinking a few weeks ago about making an emergency charger, and I've done it. And it's really simple, and it's really cheap, and it's really useful. And I can just take this thing around with me, using my cable as well, this cable here, and I can charge my phone on the go. And I can even put it in my pocket. I can leave it in the car, whatever. I can keep my phone on charge all the time. And I thought, wouldn't this be a really cool video to do on YouTube, especially because it's so good, it's so simple. So here we go. If you ever wanted to make your own emergency charger, here's how to do it. So we've got the little device. Now, how do we make this into an emergency charger? How does it work? Well, we've got an input, an output, and space for a cell. So the cell that you would probably use for this is a lithium-ion cell, a bit like this one, although it doesn't have to be in this form. As long as it's lithium chemistry, it will work, because lithium chemistry is around about 4.2 volts max, so it'll work. But what you have to do is, this will get soldered to a cell, and this one here, this micro USB here, is for charging the cell, and this one here is for draining the cell. So if I just explain, you'd plug this into your wall charger here, 5 volts in. It would deal with charging the cell up. When the cell's fully charged up, then you have the option of discharging it to charge your phone up instead. But what exactly is going on, and why do we need to do this? Because it seems a little bit complicated, doesn't it? I'll explain now. So, in a little bit more depth, what exactly is going on? So, you know, you get your DC charger. The DC charger here, we'll put it there. It's actually stepped down from 250 volts or whatever AC. It's rectified to, and it's regulated to 5 volts DC. So you get a 5 volts DC. Now, usually with 5 volts DC, you can plug that straight into your phone, can't you, to charge it? But in this case it's different because, of course, we want to charge a cell, and then we can then drain the cell later. So what actually happened is that we've got a cell here. Let's put the cell in the middle. You'll see why in a second. And let's say this is 18650 lithium-ion cell. I'll just zoom out a bit as well. So we've got the 5 volts. Can we just directly connect it to the 18650? Well, no, we can't, because the voltage of this doesn't match the chemistry of the cell. I mean, because it's lithium-ion, it's 4.2 volts maximum. If you start overcharging it, you damage it. So we need to step it down to 4.2. So there's a step here which needs to happen before we can charge the lithium-ion cell. And this step is done by the IC here. And essentially what it does is it steps the 5 volts down to 4.2 volts, again DC. So yeah, 5 volts in, the chip steps it down and starts charging the 18650 cell until it's fully charged. And that's the charging phase, if you like. Now, we say we've got the cell and it's fully charged, ready to discharge. What do we do now? Well, remember that the cell is now hopefully between 3.6 volts and 4.2 volts. If it's less than 3. Well, no, actually not less than 3.6. If it's less than about 3, then it's discharged. 4.2 means fully charged. Now, while it charges, of course, this voltage is going to drop and drop and drop. So what happens here anyway? Well, to be able to charge a phone, like my phone for example, it's used to having a 5 volt input because it wants to charge a lithium cell. So it needs a 5 volt input. So we've got a cell here which is 4.2 volts max. We need to essentially step it back up. So we're going to step it back up to 5 volts. And then from 5 volts we can then go to the phone. We can connect to the phone. So I'll just write on here, this is let's say DC charge, and here's our phone. Now, it's quite interesting actually because, oh, in fact I've just missed a step here. I'll just write 5 volts. 5 volts DC. Yeah, so let's just go over it again. We've got our charger, it's 5 volts. It needs to be stepped down to 4.2 volts. It charges the cell. The cell isn't enough voltage to power the phone, so it's stepped up to 5 volts and then 5 volts to the phone. Now it's quite interesting, I don't want to go into it in too much depth, but your phone is actually not 5 volts either, because your phone battery is also lithium-ion technology, well, lithium-based technology. So your phone is also the same as this, but for various different reasons you have to power it at 5 volts due to efficiency and whatever else. Anyway, that's how it works. So now let's get on with it and actually create the thing. Right, so what are we going to need in order to create it? Well, the answer is pretty much nothing. We need the bare minimum, bare essentials, which is basically just a cell. So I've got a cell here. Now you don't have to use this cell. You could use the flat one, the LiPo ones. You can use any lithium cells you want. And there are lots of different holders. This is a wrap holder. Now this is actually very much suited to this project because the wrap-ons don't let the cell go. You don't really want the cell to be removed, changed, etc. because it's got a charger back on it, so you wouldn't need to remove it. So yeah, these wrap-ons are good for this. However, there are all sorts available. There's nothing stopping you from using one of these. Several of these if you want to. You could probably use one of these, which is an enhanced version of that. However, this is designed so you can easily pick them out. You can also even make huge packs with these sorts of things. You can clip them together, as you've seen in one of my other videos. You know, you can do all sorts of stuff, make all sorts of shapes and whatever. Anyway, yeah, so there's all sorts, but essentially for this project it's super simple. You just need a cell and a holder, and I'll leave that up to you to decide. Right, this project is super simple. Let's just tin these to start with. Tin the ends. This is of the cell holder. On the other end. Okay. And it really is mega simple. You can see there on the little device, it's B plus and B minus, and basically common sense. The red goes to B plus, the other one goes to B minus. So I'll just clip this into place. There is something I didn't mention actually, and that's that this little thing also has other abilities. It also has it has short circuit protection, I believe. It also has overcharge protection and discharge protection. There we go. Which is good because it saves your cells, of course. Oh, that's hot. There we go. Right, snip those little pieces off. And believe it or not, that's the whole project complete. So I'm going to show you now. So what do we have here? Well, we have a cell, a little board, an excellent little board actually, the thing soldered together. And now if I simply plug this in, I can drain the cell, and this is my emergency charger. Now if I just put my phone in here, hang on. Let's plug this in. The light glows. Is this charging? Let's just check. Yeah, you can see over there, I've got it on dark because I'm fed up with this thing running out of battery. But you can see that it says charging. You see? And if I take it back, if I unplug it, stop charging. So plug it back in, and there you go. There's my emergency charger. Now, it's not a crazy capacity. These things are usually around about 2000 milliamp hour. However, these phones are usually about the same. My one is 2300 milliamp hour, if I remember rightly. It's something like that. So basically, if I was to use this thing and leave it plugged in, I could probably get around double the lifetime that I would get without the battery. So it's quite a cool thing. So yeah, there's a very simple emergency charger for cheap and extremely quick. So the next thing I'll show you anyway is the thing charging. So that's discharging. Now if I get the USB cable and put it in that way, and now connect this to a power source, just one second, I'll have to go and get one. So this is a standard USB charger, actually quite a powerful one. You can see here it says 5 volts 2 amps, which is quite good really. So I'm going to plug this in and plug this in too into the wall, and it will start to charge the cell here. Now I don't know if this is supposed to glow or what. Yeah, there you go. Yeah, if we have a look at it, there are two. Oh no, there's not two LEDs, there's one LED. Looks like one of them should be there, but they've not put it on for some reason. So I take it the blinking means that it's charging up, and if it's solid it means it's draining. But anyway, I thought one excellent and useful little project that you can really do yourself for very cheap and benefit from. I mean, if I wanted to, I could use my 3D printer and you know, do something like that. Make a little case, put it like that, and of course, because you never need to take this out, it could be concealed. You could actually do something even better and make the wires longer, and you know, put that over there, but I haven't done that. Yeah, so I just thought I'd show you this little project anyway. Hope you enjoy it. Thanks for watching. Bye.